Two robot arms reach toward a moving conveyor. A flexible wire hangs between them. In just over 2.5 seconds, they guide the connector into a socket that is sliding past, then pull back to do it again. This is Sanctuary AI's wire plugging demo, announced in June 2026. Their physical AI system hit a 99.5% plus success rate at 2.54 seconds per cycle, fast enough to match the live production speed of a global Tier 1 automotive supplier. Wire harness insertion is one of the jobs factories still do mostly by hand. Every modern car has kilometers of wiring bundled into harnesses, thick, flexible cable trees that connect sensors, lights, power, and control systems across the vehicle. The problem is that wires move. They bend under gravity, twist between connectors, and shift while you are trying to insert them. A rigid metal part stays where you put it. A flexible wire can change shape between the moment the camera sees it and the moment the gripper pushes it into the socket. And in Sanctuary's benchmark, the target is moving too. Getting the wire close is not enough. The last few millimeters of insertion require precise force. Too little, and the pin does not seat. Too much, and you bend the terminal or crack the housing. Human workers feel their way through this with fingertip pressure. For a robot, that means force sensors, contact feedback, and a control loop fast enough to react mid-insertion. Sanctuary is known for Phoenix, its humanoid robot, but this demo does not use a humanoid body. Sanctuary took Carbon AI, the learned perception and control system it built for Phoenix, and deployed it on existing commercial industrial robot arms, standard factory hardware, running Sanctuary's trained insertion policies. That is a practical choice. Humanoid robots are still years from mass factory deployment. Industrial arms are already on production floors around the world. If your AI can run on hardware a factory already owns, you skip the hardest part of selling automation, convincing a plant manager to buy a machine they have never seen before. 99.5% sounds nearly perfect, but at a 2.54-second cycle, one station runs about 1,400 insertions per hour. A 0.5% failure rate means roughly 7 missed insertions every hour, every shift, every day. On a live automotive line, 7 failures per hour is not trivial. Every missed insertion has to be caught, flagged, and either retried by the robot or routed to a rework station. If the system does not detect a miss, a defective connector goes downstream into a car. The difference between an impressive demo and a production-ready system is whether the robot knows when it failed. Sanctuary reported the number as 99.5% plus, meaning the actual rate may be higher. And the benchmark was validated against the customer's live production conditions, not just a tabletop lab setup. But without a published failure taxonomy, trial count, or recovery behavior, the headline stays a strong company claim rather than a certified production audit. Wire harness assembly remains one of the most labor-intensive processes in automotive manufacturing. That is not because nobody tried to automate it. Flexible materials, tight tolerances, and enormous part variety made it unreliable for machines for a long time. What Sanctuary is showing is that learned physical intelligence, trained for contact-rich work and deployed on real factory arms, may be closing that reliability gap. 2.54 seconds, about as long as it took you to read this sentence. One station, one cycle, one wire plugged into a moving target. The real question is whether it can do 1,400 of those in a row and catch every miss.